So we are going to practice with the rapid miner. So I will introduce a little bit about the rapid miner, and we are going to learn how to connect between the rapid miner and the Python. It seems many of you are familiar with Python, so it will be good if I connect this rapid miner with Python. But if you have little knowledge on Python, you can just keep using the rapid miner. If you want to combine the rapid miner and Python, yeah, it will be also fine. The rapid miner is an open source. Okay, actually, it was an open source, but now it becomes a commercial. That's why when you get this program, you need to use your university email address. If you are from the university or if you're from the academic, you will get the free license or the academic license. The basic for this rapid miner is Java. And now it connects to other related programming languages such as R and Python. So it means if you want to use R in rapid miner, you can also use it. If you want to use Python in rapid miner, you can also combine. And you can also use Java. You can extend more with the Java programming language. They call it low code. Low code means you can do the machine learning, you can do the data mining with very small of code or even no code. Okay? So you don't need to even make your own coding. So we call it, this is low code or no code environment, and especially for the machine learning problem. The benefit of this one is it has the connection with Python, and you can embed the deep learning function. So with some drag and drop, you can use the deep learning function, and it can connect to many other marketplace tools. Let's say you want to use R, yeah, you can connect with R. Or if you want to use image, let's say you want to use the computer vision, so it also have the function to handle the images. So it is good to understand the rapid miner. So I would like to start from the beginning again. Okay? Even though I already explained how to use the rapid miner last time, but let's figure out the details one more time, because maybe you will use this rapid miner for your team project. Yeah, it will be also good for you. Or yeah, if you want to use other programming language, including the rapid miner, then yeah, you need to understand the basic first. The two things are the repository and the operators. So repository and operators. So the repository, it consists of many examples on the machine learning flows. And the operators, it consists of many operators to do the machine learning. So what can we check from this part is so in the left panel, you can see, yeah, you can see the training resources. Okay, you can use any data, and you can use the data pre-processing steps that they already developed. Let's say you want to read the files. So what kind of data set that you want to use? So you have like this hotel app data. Okay? So you can download the data file, or you can use full repository. So yeah, there are many examples that you can use here. And the community samples. So if you join the communities, they share the materials to you. So they give you a kind of like this presentation. So it is the presentation in 2018, and they give the models. So they give what is the data set, and then what are the process for this medical data. So they give you the ETL process, okay, and they give you the way to select the feature, okay, and they give you the way to make the model, and etc. So if you have interest on building the model using the data here, yeah, you can also find the proper data. But I'm afraid that the data set in this rapid manner is not that huge. So you need to check the most interesting data for your team project. And also, yeah, this requires they provide the learners, okay, like the decision trees. Okay, so we learn about the decision trees. So you can see the result like this one. This is the tree. So yeah, we have the node outlook, and then we want to see if the outlook is overcast, then it most probably go to yes. If the outlook equals to rain, yeah, we need to check about the wind. So if it is windy, then yeah, it is most probably no. And if it is not windy, yeah, probably it is yes. So I guess this data is about the idea is the same with the data set that you use in your mid exam. Okay, so we have this outlook about the weather, okay, and then the temperature and the humidity, and then wind is true or false, and then there will be a decision. So the decision is about play, whether you want to play or not. So if the weather forecast is overcast, the temperature is 64 and the humidity is 65 and the wind is true, okay, he or she play. So play means yeah, he is going out. Okay. If no, then yeah, he or she does not play. And using the decision tree, we can get the result how the person decide about the play or not. So the final goal, this one is yes, no, is about whether they play or not. And if the outlook is sunny, it depends on the humidity. If the humidity is high, then probably he or she will not play. But if the humidity is low, then yeah, the probability to play is high. So this one is using the decision tree, and you can see this example try to use the basic concept of the decision tree that you already learned, like gain ratio, information gain, Gini index, and then the criterion like accuracy. Accuracy is for classification, and least square is for the regression. And how many depth you want to build the tree, you can define, and the confidence, the minimal gain, minimal leaf size, minimal size for the split, and the number of pre-pruning alternative. So these are the parameters of the decision tree. If you don't define any features, or if you don't define any parameters, then it will be in default. What is default? The default is gain ratio. You can change to Gini index, whether it will show the different result or not. Okay, but If the data is too small, I guess the result is the same. But if your data is quite big, the result might be different. So this first is about the repository. It can be about the data, it can be about the process, and it can be about your local repository. So whenever you have your example, you can save here and you can connect to the database. Let's say you want to use a database MySQL. So you can use this one. Okay. Oh, sorry, you need to get this database access here. Okay. In the operator, in the lower part, it is the operator. So we need to choose what are the proper operators. So you can see they are splitting into data access, blending. Blending means anything about how to connect and etc. And we have cleansing. So it is about the data pre-processing. Modeling. We have the modeling like the regression or the classification. All the algorithms are provided here. Scoring. So it is about the performance measure. Validation. So we want to check the performance with the validation approach, like the cross validation and etc. Utility. So the utility, if you check this one, yeah, it requires more function like scripting. But maybe you need to execute the SQL, or maybe you need to execute some program. So if you don't understand this, you can see the help function. So this give you the information. What is this operator? And then yeah, you will see, let's say, yeah, if it is about logging. So logging, yeah, you can, oh, okay, maybe I will see you the log. Okay, maybe later. Yeah, there are some utility function that may be needed later. And extension. So in the extension, yeah, it depends on what kind of libraries that you want to extend. So the parameters. The parameters means every operators have parameters for setup. So you can define the parameters if it is related to process or if it is related to the data. For example, if it is retrieve. So the retrieve means they have the parameters or the files that you need to access. So let's say if you have the read CSV, then the parameter, they want to find where is the file, and then whether the separator is using the semicolon or comma, yeah, you can define here. And if the quotes or the string, it can be defined here as well. Escape character. So sometimes some of your data requires this escape character. Okay, so you need to define this one. And if your data contain header, so it contains header or not, so you need to define here as well. Maybe your data starts from the second row because the first row is only comment. So you can define with these things. So the top of this rapid miner, it has design results. So most of our examples are related to design and results. So today I'm going to teach you how to use the turbo prep and the auto model. It's very convenient. Yeah, I will teach you this one later. Okay, so let's use the turbo prep. Okay. What does it mean by turbo prep? It helps the user to prepare the dataset for modeling. So from the word turbo prep, turbo, do you know turbo? Turbo. So it's very speed, okay, very quick. Okay. And then prep, it means preparation. So if you have your data and maybe you do not know what I should do with this data, okay, so the rapid miner have this function. It's very convenient, but it makes you a little bit lazy, okay, because it is all in the automatic way. They prepare for you. For example, let me use the Titanic dataset. If I want to load the data, yeah, you can use any data in the repository, or if you have your dataset and you want to put it into your local repository, that's also fine. Now, let's suppose I use the Titanic data. Okay. So I'm just using the dataset inside this rapid miner. If you want to use the import data, yeah, you can import your data. Either you want to get from your computer or you want to get from your database. So you need to make the connection. Okay, if you can connect to your local repository or any database that you want to use. Now just let me use the data Titanic, and there are 1,000 rows. Okay, so this is the basic information, and there are 12 columns, and those are the attributes: passenger class, name, sex, age, number of siblings or spouse on board, number of parents or children on board, ticket number, passenger fare, cabin, port of embarkation, lifeboat, and so forth. So if I use this data, when I double click, okay, so you can see those data now are available in this section, but you can see some of the color here. Okay, so it represents something related to the data. Let's see. The red color, of course, it is something is dangerous. What is the meaning by dangerous? You can see here, missing. Okay, so there are 20% of the data set are missing in the column 8. IDness. So it means the data has a similar number, okay, or it can be related to the ID. Oops. So the IDness, it represents the ID with the other column, so it is about like 5%. Stability, so the distribution is somehow in well distribution. Yeah. So you can see the, anyway, you can see in the below, okay, there is an information about the quality measures. So the missing is number of missing value, and the IDness is the number of different integer values for this column divided with the number of rows. And the stability is the count for most frequent non-missing value for this column divided by the number of rows. And valid, the fraction of values or this column which are not counted as missing, and it is not counted as infinite, it is not counted as ID, or it is not counted as stable. So we have like 69% data are valid. And you can check like this one, cabin. Wow, this is, the red color is high. So it means there are many missing values. Lifeboat. So in the lifeboat, it also have many issues. The missing values are 62%. Okay. Then what can we do with this one? So the rapid miner give you 5 options. Okay. What do you want to do? Whether you want to transform the data. So transform the data means, yeah, you already learned the data transformation. If we have the numerical data, yeah, we want to normalize, for example, or we want to make it into bin, or we want to make equal width, equal frequency, and etc. Cleanse. So you want to clean some dirty data or some noisy data, or if you want to clean the missing values, okay, so you can use this one, or you can generate new column, or you can do pivot. For example, you want to aggregate the value, you want to grouping the values, they have this function. Merge. If you have several tables or you have several files, you want to connect into one, then you can use this function. So let's say I want to cleanse, okay? And yeah, this is very easy for you, I guess. I do not know how I can clean this data, so I can do this auto cleansing. Then it gives you the sequence. Okay? It gives you the sequence how we can clean the data, how can we improve the quality. So the first, you need to define the target. What is the target? So here it mentioned no target column. It is a Titanic data set. We know that in the Titanic data set, the target will be the survive. We want to predict whether the person survive or not survive. So I can just choose this one, the survive, as the target. After I click this one, I can click next. Then yeah, it will give you more information. So this table, and this table, it seems it requires the quality improvement. So yeah, why they require this improvement? Because ID like. So based on the information before, ID like is they calculate the number of different integer values divided by the number of rows. It seems that the IDness is 99.85%. So it means most of the numbers, most of the values here are unique. So it seems like an ID, ID, okay? Like student ID. What is student ID? It's unique. Okay, every student have different number. So this is also the same. Name. Every row have different name. So rapid miner can understand this easily. Okay. Also the same with the ticket number. You can see that, okay, the IDness is 70%. So it has been categorized because it is like more in the categorical. But if you go with airplane, if you go with train, you will get the ticket number. the ticket number always unique. So it can be also like ID. And there are many missing in the cabin. So you can just click next. So they will give you like recommendation. And then when you have this one, change type. Are you going to change the data type or you want to keep the original? Let's say I will just keep the original rather than choosing the data into numbers or categories. And then how we can handle the numbers. So last time we already learned some basic concept about the dimensionality reduction. One of dimensionality reduction technique is PCA. And if you want to transform the numerical data, let's say the ranges of the numerical data is too high, you want to perform the normalization, yeah, you can choose this one. If you're not sure, yeah, you can just leave the setting. But okay, let's just an example. I want to perform the PCA. Okay, that's just example. And then yeah, they will give you like recommendation. Of course, this is not always correct. This is only the automatic recommendation from the system. So at the end, this recommendation will give you only the important features or the important columns. So for example, in this case, they call the passenger class as important, sex, port of embarkation, lifeboat, and survive. So the other column is deleted. So if you agree with this one, then you can commit claims and yeah, it will be your data. If you agree with this one, yeah, then you can create a process and it will create the process for you. So this is very convenient, but of course you need to understand why you need to do the PCA, why we need to replace the missing values. And if you can see this one in the sub process, there are some sub process, nominal to text, and then they again change text to nominal, and then they change the numerical to real value. Okay. So you need to understand all those things. When you do your final project, of course, you can use this easy flow from the RapidMiner, but you need to understand all the flow. And after you have this one, yeah, after you create the process, and it's good if you can do by yourself. But if you are not sure how to do the data preparation, this turbo prep give you a good alternative. So when you finish with the turbo preparation, yeah, you can generate the workflow in the design, and you can run the design and see the result. Okay. So if you have this design, you can run again the design, and you can check whether this result is the same with this turbo prep. If you think that, okay, this is not what I want, so you can redesign. You can redesign the process so it will fit with your goals. It will fit with your objective. Okay, and the other things that we can learn from here is to create the auto model. So the auto model means if your data set is ready for modeling, you can directly use this function to auto create the model based on your class. So you know that yeah, I already gave you the comments in your proposal. So some of you didn't specify what is your task. You need to define whether you are doing clustering or classification or association rule or regression. Okay, so let me go to this turbo prep. Okay, so this is the Titanic data set. You can choose the model, okay? And when you create this model, you can create the new repository, and yeah, it goes to the auto model. So I will give you another example later. What is the result of this one? We have predict, we have clusters, and we have outliers. So these three are their recommendation. So predict, it means you can do like the classification. Clusters, you can do clustering. Outliers, you can check the outlier detection. Now let's say I want to do the prediction. So you need to click on the data of the column you want to predict. Let's say I'm using the survive for the prediction. Okay, then you can go to the next, and it will give you the immediate result, how many no and how many yes in your data set. So you know the distribution, and after, if you want to select what is the benefit and cost ratio, okay, so you can define. And if you want to select the priority, maybe yes is more high interest than no, yeah, you can set this one. Let me just keep with the default, and then if I go to the next, you can select what are the inputs. Okay, so the inputs, for example, yeah, you can see the this is the attribute lifeboat, this is the attribute passenger class, this is the attribute sex, this is the attribute publication, and there are two results from the principal component analysis. So in the previous one, I select PCA. Okay, so it gives you two additional features. So this PCA is to combine from several features, and they reduce into only two representative features. And if you click next, okay, this is very convenient for you, I guess. But yeah, you need to understand, like this one, they have the decision trees. Okay, so if you click on, then it will analyze based on this algorithm. So you have all the models that has been declared by the RapidMiner. Let's say I want to use random forest. I want to use the gradient boosted tree. I want to use SVM. So all of them are the algorithms. Okay? So you can select those algorithms and run. Okay? But okay, I will choose, because if you run all of them, it takes time. Maybe I don't want to use the deep learning. Maybe I will also limit this one. Okay, and maybe I will limit this one, and then I will run. Okay. So this is very good for the initial stage. Okay. So this is very good for the first analysis. So using the naive bias, the classification error is about 4.5%. Using the logistic regression, the classification error is about 2.9%. with the fast large margin 2.9%, but with the decision tree, oh, the error rate is 20%. So you can see directly this classification error. So the decision tree is very high on the error rate. And the best one until now is the fast large margin or logistic regression. So you can see, okay, based on this one, the best one is fast large margin. Why? Because it gives you with three kind of performance measures. The first, it is the best performance with regard to the classification error. And then it is very fast. So it requires you to have the result in 7 seconds. The logistic regression give you like 4 seconds, but the standard deviation is high. For the fast large margin, the standard deviation is low. And also they compare with the other measures. For example, this one, the training time. The training time for the logistic regression is 89 milliseconds, while fast large margin training time is 74 milliseconds. And the scoring time also, it requires more time for the logistic regression compared to the fast large margin. Okay. So based on this one, then you can say that, okay, I want to choose the fast large margin for the modeling. And if you finish with this one, yeah, you can see all the results here. Okay. So the model with the naive bias is this one. You can see the weight. The weight means how the attributes show the importance or how the attribute contribute to the model to achieve the better performance. So it means life code is the most important to see whether the person is survived or not. Using the logistic regression. Okay, it shows the same. Okay. Life code is the most important features. What about the fast large margin? Oh, in the fast large margin, the principal component 2 from the PCA is the most important. And so on. So you can check all these things and you can analyze this one. So you can see that, yeah, using the decision tree, yeah, the sex is the most important attribute, but it shows the performance with lower accuracy. So the accuracy is 79.2%, while the fast large margin performance is 97.1% accuracy. So they give you the confusion matrix for this one. Okay. So you can, I think you already know what is the confusion matrix. And after you do all this one, you can open the process. So you can see here, there's an open process. So, okay, I will not save. And it gives you the overall process like this one. So it gives you the automatic formatting, okay, the basic processing, and then the feature engineering and modeling, and how they transform the data and do the scoring and the validation and explanation and weights and the simulator, and then create the model. And at the end, they do the process for all those things into the results. So the result will be the same with what you saw on the auto model. But I guess, yeah, it is too complicated to see all those things. So yeah, later when you do this one, do not use all the algorithms. Maybe you can just use the decision tree, random forest. Yeah, maybe you can start with the decision tree first. Okay. You will check what is the result in the decision trees. Although the result of the decision tree is not that good, but you can start with this one. And then you can interpret what does it mean by this one. Okay, it means that sex is the most important features. So here is the weight. Sex is the most important features. And then next, yeah, we have the discriminator, or if we want to check whether the passenger survived or not. Yeah. So if the sex is male, yeah, most probably the person did not survive. But if female, it will check. Okay, the passenger in the first class, female, most of them survive. If the passenger in the third class, yeah, it depends on the result of PCA. Okay, you can see here, the PCA is not interpretable, so you cannot interpret. So that's why when we are doing with the PCA, it's not easy to interpret this attribute. So you need to be careful when you do with the dimensionality reduction. Okay. Okay, I guess I will stop here. Okay, so I will